Hello, everyone. Welcome to the intro and deep dive session of SIG Azure. My name is Pengfei, and before the session started, now let's introduce ourselves. So, Craig, would you like to introduce yourself?
Thank you, Pengfei. So I'm Craig Peters. I am a PM program manager at Microsoft, and I work on everything that is container infrastructure and upstream open source container infrastructure software that Azure depends upon. And so Kubernetes is a key part of that, and the Azure cloud provider and all the related software is part of what I work on. My background is actually in distributed systems and open source. I've been with Microsoft for about 6 months now, working on these kinds of things. Here is contact information for myself and Pengfei.
Yeah, so we have our two WeChat contacts, so you can scan them to join us. So I'm Pengfei from also from the Microsoft, and I work mainly aiming to increase the Kubernetes experience on Azure. So I also contribute to the Kubernetes code such as container runtime and Azure Cloud Provider. Okay.
So we wanted to start by understanding who is in the audience. So first and foremost, I see some friendly faces from the Microsoft crew. So everybody who's Microsoft, feel free to say, "Here I am." We contribute to making sure that Azure runs great, and we'll be here to support your workloads. But I see some of us in the audience who are not. So I want to kind of understand who you are at some level and what you're interested in. Why are you here? So first, have you ever participated, any of you, in a SIG Azure activity of any kind? A meeting, on the Slack channel, in any way? Nope? Okay. So do you run any workloads or any Kubernetes related things on Azure today? Does anybody do that? You do. Fantastic. Great. We got a couple more people joining. Come on in. Glad you're here. So has anyone in the room used AKS Engine or familiar with AKS Engine? AKS Engine is an open source project that creates, essentially it's a template generator for creating Azure Resource Manager definitions of Kubernetes clusters on Azure. So any of you familiar with that? Nope. Okay, that's good to know. How many of you have used Azure Kubernetes Service to run your clusters? Couple. Okay. Everybody else, how are you running Kubernetes on Azure? What's your method for running? Okay, so you use a third-party platform that it somehow handles creating the Kubernetes clusters on Azure, and then it runs its own resources there? I see. So it does all of the orchestration of the Kubernetes services on VMs for you. Okay, very good. And how many of you here came here because you want some help with running Kubernetes on Azure?
So you have any question, you can hand that up.
I just wanted to kind of understand where you were going, and you know, for the rest of you who are here, I hope we can help answer some questions or raise some things for you so you understand what's going on. So okay, that kind of is kind of what I expected. So let's give you a quick introduction to who is SIG Azure and what's happening with it. So SIG Azure is in the Kubernetes community, if you're not familiar, what a special interest group. A special interest group is a community of people who are responsible for maintaining a set of capabilities in the Kubernetes ecosystem. In this case, making sure Kubernetes runs great on Azure. The chairs, I'm a newly elected co-chair, and I share the co-chair responsibility with Stephen Augustus, who works for VMware. VMware, of course, is very interested in making sure that Kubernetes runs great across all of the platforms VMware works with. And Pengfei is a technical lead along with Cal, also from Microsoft, who works in the US, very closely to some of our crew here. You can learn more about the governance of SIG Azure from this link. All of the documentation for the way in which these special interest groups operate are available online on GitHub. So why do we need a special interest group for a specific cloud, right? That's a really valid question. And the answer is that it is now becoming obsolete to have a special interest group that is focused on a cloud. So all of the individual cloud providers are now working together under a common special interest group, which is called SIG Cloud Provider. The transition for moving from the individual Azure-based SIG to the cloud provider SIG and having sub-projects under the cloud provider reflects also the change in which the way cloud providers are taken advantage of in Kubernetes itself. So we've come to a common agreement among the Kubernetes community that cloud providers should operate in a common way, so that when people are running their Kubernetes clusters on different clouds, you have a common set of expectations and ways in which you work with it. And so now we are going to transition the organization and governance around how we do that to a common methodology. That is SIG Cloud Provider with sub-projects under the cloud provider for each of the related SIGs. So presumably, I may stay involved as a co-chair of the sub-project for Azure under SIG Cloud Provider. There are several related efforts that are going to take over governance of some of the sub-projects which SIG Azure has been responsible for up until now. Right now there's an effort called cluster-api-provider-azure. That is going to move under the SIG Cluster Lifecycle project. That's also the same thing is happening for the GCP, AWS, and other cloud providers. And so all of those things are getting consolidated. There's also a sub-project of SIG Azure called the CSI drivers for Azure. That is moving under as a sub-project under SIG storage.
Yeah.
So essentially things are moving to their home, kind of logical homes.
Right. Actually, Andy is maintaining the CF drivers for Azure File and Azure Disk.
Yeah, so we've got some of the principles involved in the room. So if you have very deep questions about those, don't ask me. We'll ask Andy. So I have some references here. Once the slides are uploaded into the schedule site, you'll be able to get your own copies. I did forget to mention at the beginning that the slides will be updated online, and they're both English and Chinese copies, thanks to Pengfei for the Chinese copies. So I'll be happy to answer any questions about the transition. Oh, there's one other thing I should say about this transition, about the governance, and that is that today there is a very active Slack channel called SIG Azure. There are kind of two things happen in that Slack channel today. One is discussion about the development and mechanics of management of the Azure Cloud Provider projects and engineering work. The other kind of thing that happens in that Slack channel is user support. So we have a significant number of people who use Azure and go to the SIG Azure Slack channel to get help both from sort of Microsoft, but also from their peers in the community. And that's a fantastic thing. Obviously, the engineering work is going to move under SIG Cloud Provider, SIG Cluster Lifecycle, and SIG Storage. The user support things are going to move under a new kind of structure called user group. Those user groups, I actually don't know exactly what the structure of those are going to look like, but we'll be communicating later this summer about what the user groups and how the user groups are going to work. So there will continue to be a forum for that work.
Yeah. Okay. Next, I will make a simple introduction about the recent accomplishment of SIG Azure. So the big thing that we would work maybe in the future 2 or 3 releases, we would move the cloud provider, especially all the cloud specific codes would be out of tree. So for Azure, the cloud provider Azure has already started the work, and we have already set up the repo here, and it's also under Kubernetes org, and the repo name is cloud provider Azure. So based on this, we have also set up some end-to-end test and validated its functionality. So for the current Kubernetes core, all the cloud provider implementation have been moved to stage. So so other staged repos have also set up some synchronized to a different repo, so that for example for the cloud provider Azure, we could vendor that changes, and we're still making changes in the staging directory and sync out and vendor use in this cloud provider Azure.
Okay, can I just say a couple of words about why this is happening? So if you're not familiar with the work about the cloud providers, it might come a little out of context. An important piece of context is that historically the cloud provider code organically grew up in the Kubernetes repository. Yeah. The strength of that was that it was tightly integrated. The ability to run Kubernetes on VMware or Azure or GCP or on-prem was, bare metal, was kind of built into Kubernetes itself. Over time, that has become very unwieldy to manage very disparate kind of implementations for how you run Kubernetes on different infrastructures in that core code base. It has bloated the repository. It has slowed down the ability for the cloud providers to evolve. And most importantly, it forces the release of changes to cloud provider code to be in lockstep with the release of Kubernetes.
Yeah.
Moving the cloud providers out of tree into their own repositories allows the different cloud providers to have their own release cycles, and but it also forces us to pay a price, which is that we have to deal with the sort of compatibility matrix and the testing. So how do you version cloud provider, say, independently from the Kubernetes release? So that is all work that's ongoing in the SIG cloud provider group. Yeah.
Actually, the out-of-tree cloud provider and also the next one, cluster-api-provider-azure, they also have the same goal. So they decouple the Azure implementation from the core Kubernetes from the core cluster-api, so that we may achieve the same experience across different clouds. So maybe you need some cross-cloud solution. For example, your China business using other cloud, but your US business using Azure, so you can reuse your work based on the same solution, but the detailed implementation are different on different clouds. So the next one is about end-to-end testing. We have already established the end-to-end testing for cloud provider Azure, and we have published that result to the Kubernetes test grid, so everyone can check the status of our work. And the testing is based on AKS engine. So we use AKS engine to set up the testing environment, build the latest releases of the maybe from master branches, and validate various test cases such as Kubernetes conforming test, zero test, slow test, and so on. And the next item is about managed service identity. So for Azure, it supports many ways to authorize your applications. For example, the MSI, the user assigned MSI, the service principal, So you can choose use anyone. And but for from the Kubernetes side, so Kubernetes it needs to initialize itself and ready itself to the Kubernetes node. So for Kubernetes, we support using MSI, we support service principal, we also support user design MSI. But since the latest release last week, 1.15, we also support initialize itself without any credential. So you don't need MSI, you don't need service principal. The Kubernetes only initialize itself, get the required information from the instance metadata. So it knows its internal IP, its availability zone, and its subscription name. So it could get all of those information and compose the provider and all the node metadata and read it itself to the Kubernetes cluster. Okay, and the next one is about the AirDisk and AirFile plugin. So AirDisk and AirFile plugin are also depending on the Azure cloud provider to make a request to Azure and, for example, create some persistent volumes from Azure. So for AirDisk and AirFile, we have set up the CS drivers. So that is part of job to split to achieve the out-of-tree cloud provider. So we have set up the CS drivers for this to AirFile and AirDisk driver, and we have planned to set up the end-to-end test for them, and we have also working on the Windows support into CSI. So for CSI is for CSI on Windows, there's still some small issues we need to figure out. So maybe in the next release 1.16, we may add that support. So during this period, we have also added some new features to the two plugins, such as the Ultra SSD and the Standard SSD for AirDisk, and also the Premier AirFile driver. Okay, and the next is about Azure Load Balancer. So you know that if you use the Kubernetes service with type load balancer, then Azure Cloud Provider would set up Azure Load Balancer and the public IP, the SGs for you, so that you can access your service using that public IP. But many customers may need some their specific use cases to change the behavior of this Azure Load Balancer. So we supported a couple of annotations. So for example, you can choose your load balancer is only internal. Maybe you can use your public IP that already have created in the same resource group, or maybe in another resource group. And the last one is about many new features. For example, the auto-scaling, the virtual machine scale size, the availability zone, the cross resource group nodes. So we have moved such features from beta. From alpha to beta. Actually, for virtual machine scale size and auto-scaling support, they have been G, and it is also supported now in AKS product. So, and the last one, so if you want to check the recent updates, so what we have done in the latest release, what bug fixes are there, so you can check the Kubernetes release notes. Okay.
Thanks. So what is it that we're planning to do next? So we're bringing things out of tree. So the out of tree cloud provider is the largest piece of work that we need to do. We need to finish that work. It's a very large project.
Yeah. And then also include a couple of different projects, such as the CS drivers for AirDisk, the CS drivers for AirFile, the cluster-api-provider, and the cloud provider Azure. Yeah.
We're also working on, we're going to go into these in a little bit more detail in a minute, but we're also working on the ability to expose secrets through the storage interface, the cloud storage interface as a driver. as well as exposing the ability to use Azure Active Directory to identify and authenticate services running in your pods. And two other really cool things, which are the ability to leverage an Azure service called CosmosDB, Azure etcd for your clusters, which will give you scalability and cross-region cluster federation, which is going to be very interesting. And finally, a lot of our customers are running out of IPv4 address space, and but they also can't completely move all of their services into IPv6. And so there's a need to enable Kubernetes to support both IPv4 and v6. So we'll drill into that a little bit. So Pengfei will talk a little bit about the cluster API provider.
Yeah, so for cluster API provider Azure, it is actually set up only recently, right? So we have a couple of interns from Microsoft and from Platform 9, right? Mm-hmm. So they helped to set up the repo and make the initial work and make it working for introduce the cluster API into Azure. So today the cluster API provider Azure has been introduced in SIG cluster lifecycle. So it has been the official project in Kubernetes, and it's also brings the cluster API related project also working in Azure. So the repo here is the repo is in the Kubernetes 6 org. So here is a link, so you can have a try and get started and using them to set up a cluster on Azure. So originally we suggest using AKS engine to set up the cluster, but today you can also use this project, use the cluster API provider to provision the cluster. But you may know that the project is still in its earlier stage, so there are still some issues there. For example, the virtual machine skill set is still not supported yet. It is not supported, not because we can't add that in the cluster API provider Azure. It's because the concept from the cluster API, they don't expose the interface for the machine size, the concept, and allow the different provider to implement that. So for this part, we have already a proposal on the GitHub and published this week, I think. So everyone can comment and leave message here. So when after the proposal get reviewed from the whole community, and then we would add the virtual machine skill set there. So then it could be compatible to the AKS engine, and also we may add many new features here to support more custom. Okay, the next.
So the next thing is, the key thing is that we all know that secrets management in Kubernetes is pretty challenging, and the real need that enterprises have and have been coming to us with over and over again is that they don't want to move their secrets into Kubernetes secrets. The ability to handle that has been challenging, and we've decided to try to support this by enabling a CSI inline volume support for mounting essentially your secrets from other providers. And the initial support has come for Azure Key Vault and HashiCorp Vault. So with the release of 1.15, which just came out, you can now make those secrets that you use in enterprise service or your existing infrastructure available there. So what we would like is to understand if these two providers sort of meet all your needs, or if there are additional providers that our customers want to bring into that. So if you have a key management capability that you would like to see there, please come and help us understand the need, and if you, even better, if you can also implement a provider. So the way in which the code is structured, it's very straightforward to implement your own additional provider and add it to the project. So I'd love to hear about that. We also have now in kind of a preview form the ability to use Azure Active Directory as the authentication mechanism for the services that you're running in your pods. So you see here the link to the GitHub repo for that. It's got really straightforward documentation for how you apply that. The goal here is to make it so that your pods can essentially run different authentication schemes, or take advantage of the different roles and authentication that you have set up already in Azure Active Directory for your services that you're using for the rest of your enterprise in your Kubernetes pods, so that you don't have to create a different kind of authentication scheme specifically for Kubernetes services. The other piece of this is that you can now join nodes to your clusters and have authentication for services that aren't identified in Azure Active Directory. You can essentially create nodes that are independent of your authentication scheme. Did you have anything to add to that?
Yeah, so for pod identity, if you enable it in your cluster, then all the pods access to the instance metadata. When you get the token from there, it will be hooked by pod identity. So then you can control each pod access. You can decide which pod could get the token from Azure. Yeah.
It's a very nice feature. I'd love to get feedback for how you do that, and we're working to make this an integrated capability that's built right into Azure Kubernetes Service. Today it's supported as an add-on.
Yeah, and the next is about the running your Kubernetes with CosmosDB. So CosmosDB is a global distributed database on Azure, and it now supports the preview feature. It provided the XCD API, so then you can use this CosmosDB as the storage backend of your Kubernetes cluster. So if you set up your Kubernetes cluster on Azure, you can configure and use the CosmosDB just like the XCD cluster is installed on your local machine. So we can do this because the Cosmos have implemented the wide-level protocol of the XCD, so that every protocol that required by Kubernetes is implemented in the Cosmos XCD API. So if you want to try this feature, so you can easily follow the AKS engine's previous documents, and you can enable the CosmosDB's XCD API and join your Kubernetes class there. So with CosmosDB, since it is distributed globally, then your cluster could be easily scaled in many bigger scale.
Just a note of caution is that capability is not yet available for the etcd interface on CosmosDB.
Yeah.
During the preview phase, right now it's one availability zone for etcd data. As CosmosDB support for etcd grows, it will become available to be globally replicated.
Yeah, okay. Next one. So the next one is about the networking. We have been working to support the both the IPv4 and the IPv6 dual stack Kubernetes. So as you know that for the current Kubernetes, you could only run one stack, either IPv4 or either IPv6. So we're working on the proposals to add the dual stack Kubernetes, and also we have actually one pull request. Today is still under review, so we have also listed the pull request here. If you are interested, you can comment there, and if you have any more ideas, you can also comment there. So for this feature, we would like to, we are expecting the feature would be landed in the next release 1.16, so then everyone can try this feature and give feedbacks, and also we can improve in the next release cycle.
So yeah, in 1.16, the initial support is going to be for pod-to-pod communication.
Yeah.
The scope and the idea is over several releases, we'll add alpha support for dual stack and more of the communication schemes across Kubernetes.
Right.
The reason to do this is that the IP stack touches so many pieces of Kubernetes. As you will see with this PR, even to do this very limited scope, touches a huge number of files, and so we've worked very diligently with SIG networking and all of the other related projects to make sure that we're doing this in a very careful way, so we are not disruptive in how we implement this.
Yeah.
So I want to talk a minute about just how you can become involved, right? So you're here to get questions answered or understand why we're doing what we are. Hopefully we've helped you answer that, and maybe now you're interested. So there are several ways. One is, you already heard that SIG Azure is kind of decomposing into cluster API and storage and so forth. So stay tuned for the way the user group is going to work, and then get involved in cluster lifecycle. Join the mailing list, because that's where we'll communicate about it, but also join the Slack channel and ask your questions, get help, and figure out what's going on there. You can participate in the SIG meetings. Today, those SIG meetings occur at a time that is not at all convenient in this time zone, and we're very aware of that. In the next couple of weeks, I'm going to make a proposal for when we do the sub-project under cluster lifecycle, we're going to alternate the meeting times between Europe-friendly times and Asia-friendly times. And that way we can get a broader set of participants. To get involved in contributing to the community, starting with filing issues and reviewing PRs. So it's basic getting involved in the engineering. If you want to figure out where you can contribute, we maintain a GitHub project board, and here's the link to it. We do our diligence during the meetings to maintain and groom it and get new issues, like good first-time issues labeled, bugs labeled, and so forth, and then assign them to people and track the progress of those issues through the project board, and I encourage you to collaborate asynchronously that way. And with that, we'd like to open it up for any questions.
Here. I got it. Thank you. I have a question. What about the network plugin support policy for Azure? Because Calico has released 3.7 in last April. Yeah. And it supports Azure, and I have verified that plugin, and it can be used in a pure Linux Kubernetes class. So, does anything change about the network plugin support policy?
Yeah, actually, Calico have made some changes in the CM plugin. So before the latest release, you know that. The Calico could only be run as policy only on Azure, because the underlying protocol is not supported. But today, with the latest release, it supports VXLAN as the overlay networking. So VXLAN is also supported for Azure. So now you can run the fully Calico CM plugin and its net policy on Azure. So yeah, so we may introduce and also in the future into AKS product.
So we have time for one last question, unfortunately.
Yeah.
We used all the time. Any other questions? No? Well, thank you very much.
Okay,
really appreciate your time and attention.